The Steel Tube Institute brings together industry experts to share practical insights on HSS design and fabrication. In this clip, we provide an overview of bolted end plate splices, each offering unique advantages. We discuss how they perform under compression or tension, the differences between bolting on two sides versus all around, considerations for prying action, and where to find code references and design examples.
So when we think about spliced or end-plated connections, this is probably what a lot of us picture, are these bolted end plates. They are easy to design, they're pretty easy to detail and construct, so they're a very economical and typical option. Some of the limitations that you have to consider, though, are that the plates do extend beyond the faces of the HSS. So in some instances, it could interfere with cladding if you're at an exterior condition. So it is limited to usage in some places, but it is very, very typical. If that bolted end plate is in compression, then we assume that that compressive force is uniformly distributed through the end plate, and there are really no special design requirements for these end plates in compression. Really what you want to ensure is that the plates bear squarely on the HSS ends so that full contact is provided and that this full compressive bearing that we're assuming in our calculations actually occurs. Now, when we talk about bolted end plates in tension, however, that is another story. Once you start pulling on this spliced connection, you have very complex behavior in your plate if it does yield. So then you have bending in the plate, which could potentially have prying action. And if there is prying action, then the bolts are not only going to have to resist the direct tension force in the connection, but they are also going to have to resist any of the tensile force that's been created through the prying action. We will, of course, talk about that as we go along today. So a little bit more complex when we look at the bolted splice, the bolted end plate splice in tension. With those bolted end plates, we saw in the first slide a few pictures. Most typically what we see are bolts on all four sides of a rectangular HSS. This is more common than bolts on two sides. It is more uniform this way. And this design process is covered in AISC's Design Guide 24, Section 5.6. This is a very straightforward design procedure. And again, Volume 4 of the HSS, of the STI HSS Design Manual covers it as well. There are a few variables that you need to consider. You can see there on the screen, there is a value called P, and then on the other side, there is a value called P prime. This is the bolt pitch, or the spacing of the bolts, although it's not equal to the exact bolt spacing. It is a measure of how much of the plate is attributed to the individual bolt, if you want to think of it that way. And in most of our calculations, there is a value P in the formula. And if you have a square connection like we do here, typically that P value will be equal on both sides. But if it is not, or if you have a rectangular HSS, then the P prime distance is going to be the shorter pitch. And that will come into play because that is the value that you need in the equation, is that shorter pitch. Other assumptions in this section of the design guide are that the center line of your bolts must not be positioned beyond the corner of the HSS. And the limit states that need to be checked for this end plate connection are yielding of the end plate, tensile strength of the bolts, including prying action, if any. So this would be for a plate in tension or a splice in tension. And then, of course, the strength of the weld, which is the end plate to the HSS. So continuing on with the methodology in this section 5.6, this particular section of the design guide sizes plates to preclude prying action. So we are assuming that the plate is thick enough that the bolts will only resist the actual demand tensile forces, and they will not be amplified by any prying action. So this methodology is using simplified equations from the AISC manual in the 15th edition. That's pages 9-11 to 9-14. Those are the prying sections of the manual. So basically that means that the force in one bolt is the total force divided by the number of bolts. One thing to be aware of is that in the design guide and in the STI design manual, we use the yield strength of the plate instead of the ultimate strength. It's just a little bit different than the code. And I put the reference up there for some of the rationale behind that. And the bolt pitch P is calculated a little bit differently. Uses the full width of the plate to calculate that area that's, why can't I think of the right word, that's contributed to each bolt. That is not the right word, but it will come to me in a minute. And it's not limited to the actual spacing of the bolts themselves or 2 times the B distance, which is the offset from the face of the HSS. So if we are utilizing that methodology, then the formulas are very straightforward. The formula numbers given here are based on that design guide 24. So the minimum plate thickness for no prying is given by equation 5-23, which is just based on the demand and the number of bolts and the spacing. And then the number of bolts with the available bolt strength is taken directly from the manual table 7-2. And of course, then you must also check the weld size, which is given with equation 5-25 in the design guide. So it's all very straightforward. Moving on to bolted end plates with bolts on 2 sides. If you have this configuration, then it is typically more economical to place bolts on the long side of a rectangular HSS, only because more bolts can fit. And then you have a larger spacing than if you're trying to squeeze the same number of bolts into the shorter side. So typically it's going to be more economical to put your bolts on the long side of the HSS. And this is a good option if you have that situation where you are trying to not protrude at an exterior condition and you have a splice that you're trying to hide within maybe your exterior wall. So it is an option that we do see, maybe not as commonly as bolts on all 4 sides, but it is definitely an option. In the Design Guide 24, it is section 5.5 that addresses this particular bolt layout. And instead of assuming there is no prying action, it does take into account the complex action of the yield of the plate. And we will look at that on the next slides. But again, the requirement is that the center line of the bolts are not positioned beyond the corner of the HSS. And the limit states that must be checked are, again, yielding of the end plate, the tensile strength of the bolts, including prying action, if any, and then the strength of the weld, which is the end plate to the HSS. Design procedure for this does take into account that complex analysis for prying action, which involves yield lines. You can see in the image there that there are a couple of places where yield lines form, and the equations take into account the dimensions to those yield lines. And all of that is given in the image there. We also do have that bolt pitch to take into account as well. So based on that methodology, then the design guide gives us these equations. And now we have a little bit more complexity in them. The plate yielding value is given, and the variables in there that we saw on the previous screen also include a alpha value, which goes from 0 to 1 depending on how stiff your plate is and how much prying action is seen. And then now our bolt tension includes not only the direct tensile strength, which is just that demand P divided by the number of bolts, but also an increase due to the prying action. And that total value, the direct plus the increase, is now the value that needs to be checked against your available bolt strength directly from the AISC manual. And again, the weld size must be checked, and that equation is given as well. The third type of bolted end plate would be for round HSS, and this is discussed in section 5.4 of Design Guide 24. It goes through the analysis required for this type of end plate. And for the requirements given there, we want the bolts to be equally spaced, and we want that distance B, the offset from the face of the HSS to the bolt, to be as small as practical, and preferably we want that distance A to equal B. And there is a constructability component to this as well. I didn't mention that in the previous rectangular HSS, but it, of course, would apply there also. But that distance B from the face of the HSS to the bolt, there's a constructability issue there. We want that B to be as small as possible, but it has to be large enough that you can get your wrench in there to install and tighten your bolts. Very similar image here to what we saw previously with the yield lines occurring in the plate. So the limit states to be checked are the plastification of that plate, the yielding, the tensile strength of the bolts, including the prying action, if any, and again, the strength of the weld. So in the round HSS, that complex analysis is also taken into account, and we are given the equations shown here. And it comes up with the plate thickness, number of bolts required, including the prying action, and the weld size.
Thank you for watching, and a special thank you to the member producers who make these resources possible. Visit our website at steeltubeinstitute.org.